Hey everyone, and welcome back. Before you watch this walkthrough, make sure that you pause the video and try the problem yourself. Even a partial attempt will make the explanation that much more useful. These videos are meant to support your problem-solving process, not replace it. Across a lot of my practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the best benefit by watching multiple walkthroughs rather than treating any single one of my videos as a template that you can copy. With that, let's get started. This topic's first practice problem is all about summing up matrices. The practice problem states, given a 2D array of integers, compute the sum of all the elements. Before we write any code, I want to be very clear about what a two-dimensional array actually is in Java. It isn't a magical structure. It's just an array where every element inside of it is another array. So here, if I have an integer array matrix, then matrix at spot 0 is just an integer array. And matrix at spot 1 is another array. Each row is its own separate array. This means if I want to visit every single value in here, I'm going to need to loop through the rows first. And then within each row, I need to loop through each of those cells, often referred to as columns. This will always be a nested loop pattern. So let's get started by writing the logic as comments first. I've started my main program here by just defining my 2D matrix, my 2D integer array right here. As you can see, normally when we define a one-dimensional array, we have one set of square brackets. We just say an int array matrix, meaning an array that holds integers. Here we have int array array, meaning we have an array which holds int arrays. We can see how that translates from what we previously understood about how arrays work and are declared. I've written a print method that will just go through every single row and print out the array just so that I can see it. And then once that's done, we can get our sum elements going and actually write the algorithm that we're intending to write. To make sure that this works as intended, we can go ahead and run this code, compile, and run it. And we'll see that we get our two rows as we'd expect, printing out one at a time. All right, let's go ahead and add in that int sum call, where we're going to sum up all of our elements right here. And then we can go ahead and add a print statement that says the sum of the matrix is, and then we'll just print out our summation right there. Of course, right now that would just do 0 because we haven't gotten into the meat of this algorithm yet. The very first thing that we need is going to be that sum variable, which as you can see, we've already put in. Since we know we're going to be running a count over all of our elements, we know we're returning an integer, I've just set that up here and returned sum. Now, just like in recursion, it's always nice to think about what our smallest case is. Here we don't have recursion, but by recognizing that an empty matrix would return 0, this is allowing me to recognize that my initial value here should indeed be 0. Now what we need to do is we need to tell ourselves that we need to loop through each row. And then for each of those rows in this array, we're going to need to loop through that row, because that row is still an entire array, as we see on line 5. So for each row, we're going to need to loop through the elements in the row array. Every single element will be an integer, and so what we're going to need to do is sum up these values. Now, just so that we can see two different ways of solving this problem, I'm going to go ahead and do a for each loop and a regular for loop, just so that we can see how both of these lines would translate to code. The first thing we have here is that loop through each row. So as you saw in my print method, I'll go ahead and just say for each row, and the row is an integer array, in our matrix, we want to do the following work. Then we have our loop through each element in the row array. So my row array is row here, so I can say, for int I is equal to 0, I is less than row dot length, I plus plus, what are we going to do? We're going to sum up the values within that row. Now you'll notice that this row variable is already just a single array. So it's as simple as writing sum plus equals row at I. Now in future videos, I will actually show using 2 for loops so that you can see how we would need to reference this if we didn't have the row array. But for right now, this is our complete program. Let's run this just to make sure that it works. We'll compile our code. We'll clear out the old response there just so that we can have a nice clean space. And when we run it, we do see that the sum is appropriately 21. Now, it is worth noting that I'm able to reference the row through this row element because I have it right here, row at I, and I've created it in my for each loop. But it's important that we understand what might happen if instead of a for each loop, this was just a regular iterating for loop. For int j equals 0, j is less than our matrix length, j plus plus. So this actually changes quite a few things here. The first being that we don't have this row variable anymore. So what does this need to get replaced with? Well, we could replace it with matrix, but this may not work. And this may not work because while we do have 2 rows, there are 3 elements in each row. So matrix here would be, matrix.length would be 2. Matrix at 0 is going to give us 3 because that's how long the array in the first row is. Now, there is actually no guarantee that all of the integer arrays within our matrix are the same length. In this example, they are, but in order to be safe, we're going to actually do matrix at j so that every time we're actually just getting the number of elements for a given row. Now, when we want to sum up the values in matrix at j, this can't be row anymore. We need to go to matrix at j. Whoops, there we go. And within matrix at j, we need to go through each element at I. Sometimes these iteration variables here are these variants, we'll call them, these loop variants, are renamed to row and column, just so then that way it's a little bit more clear how we're referencing our row and column. I and j is kind of arbitrary. It makes sense, but if you're struggling a little bit, making your variables row and column can help. So now I can go ahead and rerun this. I'll compile and rerun, and we're still going to get 21. Now, like I said, we don't actually need every single row to be the same. So if I add a 7 and an 8 here, so now we've got 1, 2, 3 on the first row, 4, 5, 6 on the 7, and then 7, 8 on the third, we should get an answer of 36. Let me make sure I've saved that. We can recompile, clear out our space, and run it, seeing that even though they don't have the same number of values, it still works successfully. That's it, and now we've solved this problem. Now remember, you won't find my solution posted alongside this video. If you watch the walkthrough without first attempting the problem, stop here, close my solution, and try to write it yourself now. Post-walkthrough practice still counts. If you have questions about this problem or suggestions for future practice videos, please be sure to leave them in the comment section below. Thanks everyone, and I'll see you next time. Bye.